Boys and girls, in this video, we are going to look at the first of what are called conditional statements in C. Conditional statements are ways of letting us use logic that look different than the linear line by line logic that we've used in all the programs that we have seen so far in this course. In a conditional program, what you can specify is that if a particular condition is true, then you do one thing, and if it is false, then you do something else. The way that we generally write conditional statements in C is typically using an if statement. Let's take a look at what this if statement is doing in this piece of code. So in this piece of code, I have a salary and a loan variable, and the loan is either approved or not, where by default we just say that it is not approved. We set it to 0. And essentially, in the program, we write this if statement. Look at this part here. We write this if statement, and then we specify a particular expression. If salary is greater than or equal to 400,000. And basically, if this expression evaluates to true, then whatever is in this shaded area, whatever code exists in this shaded area between these two curly braces, that code is executed. This code is executed only if this condition is true. If not, then this code is skipped over. So the loan is not set to 1. The interest rate is not specified, but we continue to do other stuff in the program. Notice the syntax here. You have this simple bracket to store the expression that has to be evaluated, and you have this curly bracket to store the code block that is to be conditionally executed. Be always careful in not switching these two. The expression that is to be evaluated is stored within simple brackets. The code, which can be multiple lines of code, which is to be evaluated conditionally, is stored within curly brackets. You don't require these curly brackets if there are just one statement in the if condition. But if you have multiple statements in the if condition, then you have to have these braces. You can't do without them. The testing condition will give either a 0 or a 1 value. That is what is needed in order for the code to execute. What you can also do is you can use an if-else statement. So in this case, the if block has these statements. We modified it slightly. And the else block has a different statement. In this case, I did not need the braces in else because there's just one statement. But it's always good practice to put the braces in anyway. And so that's what I'm doing. But what you have to realize is that this code executes in a branching manner. So if the salary is greater than 400,000, then this block executes. And if the salary is not greater than 400,000, then this other block executes, which simply just prints, sorry, your loan cannot be approved. And this is the way the branching structure can be implemented. There are multiple ways of using the if-else statement. The simplest is what I showed you at the very beginning, where we just specified a condition and we had some code in the blocks that would execute if the condition was true. There's no else statement to be used. You can also do it the way I showed you secondly, where we have a condition, and if the condition is true, one block of code executes. If the condition is false, then the block of code that is within the else curly braces, that block of code is executed. But You can also have more complex situations where if one condition is true, you execute one set of statements. Otherwise, if another condition is true, you execute a second set of statements, and otherwise, you just execute whatever is contained in the else block. And this can be generalized. So you can have as many conditions as you want, and all of them have to be chained together in this else, 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 else structure. So at the very beginning, there's an if, at the very end, there's an else, and you have these multiple chains of else if conditionals that implement this multiple condition check such that any one out of these n+1 blocks of code will execute. It is also possible to have nested conditionals, and this is where things get really, really messed up in your annotation, because it frequently happens that you will miss some curly braces or the other in your code, and you'll get compilation errors and logic errors. So be careful. Let's walk through this nested conditional a little bit carefully. So for ease of reference, I've set the first level conditional as in red, and the second level conditional is marked in blue. So what will happen? If condition 1 is true, then the execution of the code will enter into this block inside the big braces that I have up here. Now within this, there is another check. Here we ask the question if condition 2 is true. Now if condition 2 is true, the execution of the code enters this small brace here, and whatever is in this brace is executed. Otherwise, whatever is in this else brace is executed. So if condition 1 is true and condition 2 is false, then whatever is inside this else brace is executed. Now, these are the two possibilities within condition 1. Either condition 2 is true or it's false, so one of these two blocks would execute. If instead condition 1 had been false to begin with, then we go into the big else block, and within this big else block, either condition 3 would be true or it would be false. If condition 3 was true, then the code within this if block would be executed. Otherwise, the code in this else block would be executed. So this is all very logical. There's nothing here that is strange. It's just that the syntax is intricate, and you have to remember to always match these braces. So if you don't match the braces, and if you don't match the number of ifs and elses, you're going to get compilation errors, you're going to get logic errors, you're going to have a tough time debugging your code. So always be sure whenever you create an open curly brace, you match it with a closed curly brace when you're doing these conditionals, because otherwise, as the complexity of your code increases, debugging it becomes a massive, massive challenge, and you will be spending a lot of time on it. One thing you have to be very careful with when you're using if else is that if you don't put curly braces in, which you may not if you just have one statement to work with, and if you're coming to C from Python, for example, let me give you a cautionary example for what's going to happen to you when you try and use Python logic in C. So let's say that you wanted to say if A is not equal to 0 and if B is not equal to 0, and if the product of A and B is greater than equal to 0, then we know that A and B are giving a positive product. Otherwise, you know that one of the numbers is 0. So What you're trying to say is that if I know that if A is not equal to 0 and if B is not equal to 0, if I already know this to be true, um, then we execute whatever is in here. If either of these conditions is broken, then I know that at least one of these numbers is 0. So that's the logic I want to use. I'm saying if this is true, then evaluate this, otherwise print this. And since I just have this one statement here and this statement has this one statement below it, I say, well, I'll just not use braces. But then what the compiler is going to do is it's going to treat it like this internally. It's going to say if A is not equal to 0 and B not equal to 0, go into the control block here, the if condition, and here the else that we put down below, which we thought we were matching with this top if, is matched with the bottom if. And the logic of your code is broken. So this is certainly not what we wanted. What will happen now here is that the if A not equal to 0 and B not equal to 0 condition is going to be fired. And if A times B is less than equal to 0, well, is less than 0, we'll print one number as 0, even though it isn't. So you have to know that the compiler is going to match the if and else by closeness. So any else that it finds that it cannot match based on the curly braces, it will match with the closest if above it. That is what the compiler is programmed to do. It will deterministically do this. So always make sure to use braces. Sometimes it'll feel like using braces is cumbersome, and in fact, we'll see some examples where using braces is not great. But for the most part, unless you have a very special requirement, you really should use braces when using if else. This is not Python. Mr. C will not care about how you did the indentation. In Python, this program would work because in Python, indentation is what determines the control flow. But in C, indentation does not determine the control flow. The compiler does not see it. It only sees the braces, and so you have to be careful with the braces. Let's just use one last if-else example, and then we will close this video. In this particular case, I have this slightly intricate expression. What do you think is going to happen? Well, Mr. C will tell you that he will simply print 5, 6, and 7, which is what you would expect if the else block had been implemented. Notice here that after having exhorted you to use braces, I have not actually used braces here. That's because I know that this is a simple piece of code where there's just two different printfs and using braces is overkill. So keep that in mind. What I said just 2 minutes ago is sort of a general principle, but it's possible to stretch it too far. So for simple code like this, you don't need braces. I haven't put braces. So anyway, why is Mr. C doing this? Mr. C is doing this because if you remember your precedence and associativity calculations, the the precedence of these relational operators is from left to right. And so I greater than j is evaluated first, and this evaluates to false, and that puts a 0 here, and then the question is asked, is 0 equals 7? It's not true, so you get 0, and that pushes the control to the else block. All perfectly logical, as long as you are able to think clearly. Now let me finish this video by saying something even more contradictory. I just told you 3 minutes ago that the C compiler does not see your indentation. This is not Python. But I will still say you should use indentation. This is a main statement. This is a dependent statement. We are going into the control block based on the logic of the main statement. Main statements are statements in the main control flow of your program as determined by the hierarchy within the main function. Dependent statements branch off from the main flow, whether they're using if or they're using some other statements that we will see soon. If you indent them, this will not help the compiler, but this will help you, and it will also help other people who are reading your code. So be sure to use indentation. It will help you and it will help people to evaluate your code. As I already said, this matters more in some languages like Python, but even in C, if not for the compiler's sake, for your own sake, please use indentation whenever you can, and as long as it makes sense in the logic of your program. One issue which bedevils people when they start programming at any level of complexity is whether to use 4 spaces or just the tab key to indent. And the golden rule here is to use 4 spaces rather than tab to indent. Why exactly is this? The reason for this is that in some IDEs, the mapping from the tab to white space is 4 white spaces to each tab. In others, it is 6. In others, it is 2. And so when you try and read this code programmatically for some reason, it ends up creating problems. So if you are doing big collaborative projects with other people, which you might be in future, if you use tab to indent, in some cases you might run into conflicts. And so the safe programming practice is to just use 4 white spaces to indent. This brings us to the close of our if-else lecture, and we'll be looking at switch case in a different lecture soon.